Hi everyone, this is Antonio Perez. This is Blueprint Reading for Construction, Unit 10 Foundation Prints. I'm going to go over the PowerPoint presentation, and then after we finish that, I will try to go over some of the activities and help with getting some of the homework assignments done a little bit more easier, a little bit more faster. So let's begin. So our learning objectives, what we're going to be doing in this unit, Unit 10, we're going to identify footings on a foundation plan and describe different types of foundation support systems. Identify various components of a foundation system. So if you don't know what a footing is, I will explain. That is a component of a foundation system. Okay? And footings are the base, the footprint of a foundation that supports a building. And those are called foundations. So some of the technical terms. Auger cast pile. So a cast pile is dirt that gets from when you drill a hole, from when using an auger. An auger is a drill bit that makes a hole and removes the dirt. Can be done by hand with two people, or small holes, or it can be done larger holes with a tractor. Think of it as a drill bit that a machine uses to drill into the dirt to make a hole. And a cast pile is the dirt that comes out of that hole. A basement plan. So a basement plan is a plan that you would look for to find out how the foundation and any under crawl spaces. A crawl space underneath the house that you can stand in is called a basement. So if you're not crawling around, but you actually can stand up, it's called a basement. So a plan that shows the space with stairs going under a house. So think of it as floor 0. Floor 1 being the first floor that's right off of the ground. Caissons. That's a new word for me. We'll see if we can answer it. Caissons. Concrete masonry unit. So one thing you want to remember is that a particular design is going, and a foundation is pretty much the same shape. It's just that this particular shape travels a distance that's usually measured in lineal feet. So when you look at a cross section of a detail of a foundation footing, you'll see that there's a footing, usually a footing, a stem wall, and then within that you'll see the steel that's embedded within the concrete that represents that foundation wall, either stem wall or larger retaining walls. But they both rest on top of a footing, which is the bottom, the base, which supports the structure. And it's usually, I've seen it in the shape of a T, for example, an upside down T. So that's measured in cubic feet if you're measuring the concrete or the dirt that is removed, and then the space that is filled. You're filling a space that's measured in cubic feet or cubic yards. Sometimes we measure something, its length, that's considered a lineal measurement because it's in one direction. But when we have multiple directions, where we have the length, the width, and the height all in combination, well, those numbers can be used to multiply against each other, mathematically speaking, to figure out what the cubic feet are, or the actual space that's enclosed. So that being said, they can be broken up into units. So when you count the length, if you know the measurement of 1 cubic foot, then that's what's considered a masonry unit. Like one lineal foot of a particular wall. And that particular one lineal foot would represent so much amount of a cubic footage or a cubic yard. So it could be a percentage of cubic yard, for example. Then all you at that point will do is measure your lineal footage and multiply by that unit that you've used to determine what one lineal foot would represent. Expansion joints. They're breaks in concrete to allow for the concrete to move around, and with heat it'll expand and get large to a point where it might touch each other, and you don't want the concrete to buckle or crack. So allowing some room for the concrete to expand and contract is called an expansion joint. A floating slab construction. Think about it. You have a slab, which is basically a flat surface laid on top of the ground surface. And it's just laying on there. There's no footing. There is no perimeter concrete wall. It's just flat concrete said thickness. There may be bars in it, but it's considered floating as it's just laying on top of the dirt. Footings, as I mentioned earlier, is one of the components of a foundation system. It is the base. It's the footprint that supports the structure that gets built upon it. And it'll include a stem wall that is cast into the footing or attached to the footing. Now, a foundation plan shows you the outline, the plan view, looking down from the sky down to the flat surface, the area that it's going to take, that's going to be consumed in this foundation. And a foundation plan will show you lines that represent lines above ground and below ground. Remember, dashed lines being the hidden lines. The dashed lines represent the objects that are underground, under the dirt. Yes, you may have to remove dirt to access that, but then you may be putting the dirt back after you've poured your concrete footing. And so that finished footing would be as it's seen on the plan, with hidden under the dirt. And the dashed lines represent the footprint that footing is taking. Friction pile. I'm not sure what a friction pile is. We'll find out about that. Frost line. A frost line could be the frost line in the ground, in the dirt. Sometimes the ground gets frozen, and there's a certain line that once you dig so deep, the ground stays frozen even in the summertime. You might be living in Alaska or one of the northern countries, or somewhere that gets snow for most of the year and the ground freezes. So it might be spring, but you don't dig very far before you find frozen ground. Cases like that, you need a tractor, and even then it's hard. Or that's what I think it is. A grade beam is a type of foundation system where the foundation is all connected together so that the whole foundation represents a distribution of weight. And if there's any movement, it kind of goes down together. Or if the ground starts to sink underneath, the foundation is connected together. So if there was space, it would try to hold itself up. It's just a way of distributing weight so that areas that have a lot of strong support will carry the areas that might have some soft support. And that way you don't get cracks in the walls or cracks in your foundation due to the ground settling. Keyway. Keyway is a groove or a channel that it's laid in or made into the footing, the square footing. And when I mentioned that footings and stem walls are done in two parts because the footing is wider than the wall. So the wall rests on top of a footing, but it'll be attached. They'll pour another batch of concrete on top of it. And there will be a keyway so that the concrete is not poured flat against flat and that moves. There's a channel so that when you pour, the concrete can't move because it's like Legos. It snaps into a little groove. Think of Legos, except a long skinny channel instead of round holes. A monolithic slab. It's just saying it's a slab that's made out of one. It's one slab made out of one piece and one pour. So it might be a slab that includes walls or raised areas where walls might rest around the exterior, even in the interior of the building. And it has footings or stem walls above it and maybe footings laid underneath. And a slab all in one liquefied pour. That's a monolithic slab. A slab on grade is like a floating slab right on top of the dirt. But the grade might be sloping, and so it might be thinner on one end and taller on another end. A steel pile. That is like a cage of steel, like a spiral of steel with bars in it all wired together, and you slip that cage into a hole that would get bored with an auger. And so once you've removed a pile, right, you put in a steel cage that would go into the long hole. And that's what the pile is considered. And so then when you pour that hole with concrete, now it's a long hole with steel embedded in it and concrete. Waterproofing is different. It's like roofing, except it's now basically weatherproofing material that keeps water from getting into or under the foundation or through a wall. Especially when a wall is holding up the side of a hill. That hill might be exposed to a lot of moisture that runs downhill, and your building is up against the side of the hill. You would put waterproofing and then some form of drainage so that water doesn't collect along or underground along the building, on that high side of the building. And a water stop. I'm not sure what the water stop is considered in this application. There's so many different things I can think of a water stop. So let's go on and we'll get into the chapter. Here we go. So in our introduction to foundation prints, the building structure consists of two major components: the foundation and the above grade framing system, right? So a building is framed and built on top of a foundation. So the foundation is that first concrete component, sometimes wood, but not much, that meets the dirt, meets the ground, where the building meets the ground on the dirt, usually at the foundation level. Types of foundation systems. You got footings and walls, grade beams, auger cast piles, caisson, and steel piles. Okay, so these are all considered different types. So I have I had spoken about the steel pile, the auger cast piles. I thought they were connected. We'll see. And then we're going to get an explanation of caissons. So let's go on. Footings. So the feet on which the entire building rests. I like to say the foot or the footprint. But it is the whole area that rests on the ground. So you can consider it the whole, like the foot or the feet, shown as hidden lines on a foundation plans. It's that parallel dashed lines that go out throughout the that travel throughout the plan. They must be read in rest on undisturbed earth below the frost line. Okay. So again, the frost line probably has to do with some level at which the ground freezes. And so they got to be on ground that's below the frost line. So that's saying that if you go deep enough, the ground won't freeze. So if you're not in one of those areas that gets subject to freezing, then this is not much of a concern. But if you are in an area, it means you're going to be digging deeper. You're going to find that frost line and be below it. So your foot or your footing may be pretty far down below the frost line. Footings are reinforced with steel, known as rebar. Footings are determined by the weight of the building and the type of the soil. So the very beginning of the project, the owner would acquire what is referred to as a geographic soils report. And it would tell you the type of soil that you have. And then, depending on how many floors you're going to have and the type of soil will determine the type of sizes of footings will result. So when you get plans, some engineering had been taken into consideration with the type of the soil and the weight of the building, and then from that determined a footing size. So footings might be similar in shape and even size, but not always. You'll find that there are areas where they will get heavier or thicker to make them stronger, or they will add more steel reinforcing. So here is an example of a plan, and if you look at the bottom, the title, it says Foundation Plan. So this particular house that we're looking at, you can see in this elevation, this front elevation, you've got front garage with a little roof pitched on it until you hit the main house where you have two different pitches. You've got this section of the house to the center, and then you've got these little rooms over here. So with a roof pitch running down the center of the house here. Okay. When you look at the footprint, you can see the dashed line here. And you can see the dashed line going around the outside. There doesn't seem to be a dashed line over here, which I think is strange. Although there is around the other sides of the garage. So there may be a purpose to that. Maybe we'll find out. Wall footings. They support concrete foundation walls. And they typically have a key way to help anchor the wall. So that's that groove. So it's a wall built on top of a footing. And if it's not done monolithic, all in one continuous liquid pour, then you pour the footing, which is a rectangle that lays on the bottom, and then put the wall on top of that. And it would be anchored together with, you'd have an anchor steel, so that when you poured coming out of the new pour and the first pour and the second pour, you will have steel. So once you pour into that steel, then they'll be attached, the two, and also the keyway helps keep things stable so they don't move. And I'll explain and I'll show when we see a picture of that. A plan indicates the top of the footing, TOF, or T and FTG, right? Top of footing, TOF, or T/FTG. That's what the plan indicates. So that's what you see when you're looking at a plan. You see the tops of the footing elevation. So here is an example of a plan. You can see it's a broken line. So we just see some dotted lines that come to this square component here. Then a square component, hidden lines that travel this direction. Again, a little square outline. Dotted lines, right? Continuous dotted lines that run along the wall. Then at a certain point, like the corners or this alignment with this column, you see, there happens to be this little larger pier. Okay, so we will look at the at the anatomy of that. Okay, so everything you see here, let me adjust my mouse. Okay, moves a little faster. Everything you see here in this is the partial foundation plan view. Over on this other half is an elevation, so you can see what's happening. So the dotted lines that you see represented on the plan represent the footing from here to here. Here is this keyway, that groove. See this? The red represents the steel bars. This is a round bar traveling the length of the footing. This is also another round bar traveling the length of the footing. And then every so often a steel bar will come out, usually 16 inches on center, up to the next level, where you will have a stem wall, which is this guy. And this stem wall is where you would pour in a second pour. You'd pour this first guy, and then later put a set of forms, and it shows you it's broken here because the stem wall can be really tall. And on one side it could be under the house, the other side the dirt might be all the way up near the top, supporting the dirt away from a sloping hill. So that's why it's broken here, because it's saying it could be any length and height. So as you can see, here's the footing, the concrete wall, the red reinforced steel. Here it's showing you the elevation going sideways. Here it shows this way on the left. It shows it going like this, straight at you. And then on the right, it shows it what it looks at from the side as it goes from left to right. And here are the steel bars every so often. That's these guys in the L-shaped. And what we saw here in this picture is little dots, is 2 bars here, 1 bar up here, 1 bar up here, traveling horizontal the length. So that's what you have. And when I spoke about a masonry unit, you take this shape and figure out what its value is in material at 1 lineal foot of traveling this length, just traveling 1 foot. Now these corners are special. They're saying the footing gets bigger, and then it stops there. A wall beam spans the wall footing. Top bonding elevation, top of TOF. Top of footing elevation at 89 feet 4 inches. Okay, so usually that's a measurement of above sea level. And here it says top of footing elevation at 91 feet 4 inches. So 89, 90, 91. So at some point from here to here, the footing went up in height. Right here it says the footing step. Here it is, you see it. So top of footing, here's the step, here's where it changes in height right here from one to the other. It's called a pilaster. It's just showing you that it's coming out. And, I think it's so you got the column and the column footing. So over here is another little pad, a square area where concrete's going to be poured. And then right in the middle, it's either going to be concrete column or some kind of wood. Yeah, concrete column. So a little square column, little square guy like that, sticking right up out of the top of it, and it's going to support a beam overhead. And that's what this dashed line here is showing you, that they're lined up with each other. That this square and this square and this little square and this little half rectangle, center to center, line up with each other. Now this might look very busy and kind of scary and what has to read, but we look down below and it is a foundation plan. So if we had this set of paper in front of us, or if we could zoom in and out easily, we would start reading it. And all we really need to do is establish our foundation types and our units, and then just start measuring. So if there's pilasters, we measure and count the pilasters. And if there's a footing and a particular shape and a particular height, then we determine that footing. And if it changes in height, then it's going to have a new unit, because every foot's going to have more material in it. So you separate where and count and measure, or keep separate measurements for the different types of footings. Now I say measurements because when you're building the footing, it'd be different measurements. And also when you're estimating the materials, it's different measurements. What do I mean by measurements? They were different shape of a certain type of foundation. It had a footing and a wall, and maybe the wall is taller and has more steel in it. Or maybe the wall is shorter and has less steel in it. So you would keep track of the lineal footage of the different types of wall, or that have the different types of foundation unit measurement. A unit measurement. Basically, how much does 1 foot measure? And then if you've got 30 feet of that or 300 feet of that, then you count that. If you have another type of unit that measures a different size, then you got to count all of that separate. So again, these look hard to read, but you can see the dashed lines that travel around the perimeter of the wall. Everything you see in a small dashed line and going around the outside of the building is going to have a type of footing. And then there'll be a note attached to it with a detail saying, this is detail. Right here you can see a detail or an elevation showing you this section right here. Right here, there's a detail and elevation showing you the section across that footing. And then that footing is the same, but then it changes here. So you see right here, there's a detail going across the footing in this direction, going downward. Then there's another detail, and if it's a different number, because this one says 3 and this one says 4, I think this footing changes right here, from here to here. And so you'll see a different detail. See, this is a detail going across the footing there, detail going across the footing here, detail going across the footing here. And if they're the same number, then they're the same detail. If the numbers change, then the details change. When I see this one, I see 3, 4, and 3. The top of the circle there's a 3. And then the bottom of the circle is the page number. And you can see that it's showing you an arrow pointing the direction that it's looking at across that section. And then don't be afraid to use the notes. These notes transfer to numbers that are written on here. So all these little circles, and these are all little symbols. They represent the notes. Here's a close-up view of those notes that I was telling you about. Now, there's the dashed line showing you the hidden line of the foundation. Then you have this section number. You see 3S 3.1. So that's detail 3 looking in a section looking sideways from right to left. And it's on page S 3.1. And S usually represents the structural pages. So remember S for structural. And then on S 3.1, you'll find a page. Then look for the location for drawing number 3, and it'll show you what it looks like through this part of the foundation. Then over here is 5S 3.1. So somewhere here, you can see going across this section, there's a little flag, that the foundation changes from here to here. So we have to figure out why. And we might see that in an elevation. So, see, here's the detail 3S31. It just happens to show it here, 3S31. So we see that it consists of a footing with the stem wall. The footing is 1 foot tall, 2'6" wide, with a stem wall that rests above it. Looks like 1 feet wide, with 9 inches of a step on both sides. So 2'6" minus 1 equals 9 inches on both sides up on top. And then you see this guy, it's got 2 feet of dirt on top of the 1 foot. So here you've had to remove 3 foot of dirt. And here it tells you minimum you've got to remove 2'6". So, or minimum you've got 2'6". So in some areas that may change. You may have to remove more or less. Then what you see happen is, oh, you see the 2.0 is up here, partially out of ground. That's where the minimum 2'6" is, because there's 3. So that's saying that if this was 6 inches sticking out of the ground, that's where the minimum 2'6" comes from. Okay. And then that's the top of the wall, and from that point you've got 2'11" that continues walls up. On the other side, it looks like there's an elevated floor. And here it says that the top of the wall has a stone cap on it. And then on this side of the wall, it looks like it's got some stone veneering that gets glued on the side. Glued, when I say glued, it gets attached masonry with mortar. You can see the steel bars that are embedded. These bars, these L-shaped bars. Here it tells you number 4 vertical at 18" on center. So that's what it is. It's a number 4 steel rebar, 18" on center at each face. And then you've got 12 inches concrete wall with number 4 horizontals at 12 inches on center for each face. And it looks like you got them on 2 sides. See, for each face. So you got one side and the other side. That's why they say each face. So then, really it's 2 bars back to back. So what you read here is what you read here. And that's it. At that point, this is enough for you to know how you would be building the structure. Okay? And this is a little wall. It's a short little wall with a stone cap on it. And it's got pavers on one side. So right here, it's like a patio wall or something of that nature. Because it says there's pavers on this side, on the inside. This is a dock leveler. Okay, so what we are reading in these plans, right? From the plan view, you can see that I've got 3 sections, 10, 9, 10, and 12. So this foundation is a little bit different than this. Let's see. From here this way is the S3. This guy from the middle of the foundation on the front is a 9. This one's a 10, this one's a 9, and this one's a 12. So they could be similar in shape in that they both, follow the same footprint and the walls in relationship, but they change. So let's look at 9. 9 shows you the hidden lines, and then something's happening out here, way out here. See, more than you've got this little level here as well. Okay. So you can see that this looks like steps. It's a dock leveler. It's a way for a vehicle to pull up to the back of a higher plane. So you see this little symbol, circle with the X through it, the corners blacked out, and there, that's telling you that that's at an elevation, a height, a specific height. So there's a relationship between this level and this level. So you're just looking at 2 different levels from the side in this section. So it's lower down here and higher up here. And you can see there looks like some sort of wall going hidden behind this. That's going in this direction. Let's see if it'll show us more. So here it only showed us one type of section through here. So it's just how we read it. A retaining wall. You can see a retaining wall. Over here the soil is holding up dirt and keeping it from dropping into the lower level. There's a footing with a stem wall, and see it says lower side of earth retention, because on this side the dirt is lower. You can see a concrete floor. See this little elevation is telling you the top of the slab height. Then it's telling you the top of the foundation wall height. Then it's telling you the top of another floor at another level. So there's dirt higher, the wall drops, it supports the dirt on this side. And so it's like a way of building on the side of a hill where it drops like steps, different floors. So the higher earth side has a load on it because there's more dirt weight upon pushing up against the side of this wall and pushing down. So columns. Columns are just a little vertical square object or a vertical round object. So what you see here is the footprint at the base, at the ground, and then this square object, notice it's a solid line because it projects and it continues up. Whereas the dashed square line below, that represents the footing, the base that's down below at the base. And then you see that it's got a note to it saying number 2, which would describe some, there'd be a note that says what that part is. But you can see here the dashed line says footing 3'6" by 3'6". So this is a 3'6" by 3'6" square by 1 foot 4 inches. So it's 1 foot 4 deep with 4 number 5 EWs at the bottom and top footing. So the T of the footing, the top of the footing, is going to be at 95 feet 6 inches. Nothing's measured at 95 6 feet. They're talking about the elevation, where the top is going to be, and that number is based on the measurement of above sea level. So in reality, it might be 6 inches above your ground, 8 inches above your ground. Okay, but maybe your house is on the side of the hill, so you're going to be keeping track of the different numbers above sea level, but so that you have the relationship of the floor one to the other. So here it says 95 6 inches top of footing. Here 95 6 inches top of footing. So those are equal in height. They're not sticking out any different. So these two are basically the same. And that's why they have the number 2 note next to them. And if we were to look at a section of that footing, you'd see that there are the 5 bars of steel. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Number 4, number 5 with the bottom. You got to be able to read those notes and understand. 4 3/4 inch diameter anchor bolts. So these are anchor bolts, not steel rebar coming out of them. And the steel comes out, and this column here, the center line of that column, it's 1 1/2 inch base plate, diamond block, concrete fill, 3 inch larger than base. Looks like this is a piece of steel column because that gets bolted down on top of this footing. Diamond block out with concrete fill, 3 inch larger than a base plate or column, pier all around. So this is like a floor that gets poured over the steel bolt later. And then because you have a base plate, it gets bolted down. It's on top of some type of grout that helps level it. And then you have this bond breaker, this little space. It's like you pour the footing and then you pour this little separate section. So that we looked at a column, we looked at the footings. Now let's look at some more of the foundation plan. You can see here that we're looking at piers that are round, concrete column, and a concrete pier. So this square is a concrete column. I guess that previous one was steel. And then instead of making a square hole, you can make a round hole this time. And they call that a pier. And the top of the footing, so you see here, you got top of footing elevation, 832.25, again, above sea level. So if I had 832.25 and over here it's 832.25, 832.25, 832.5. So something is a 1/4 inch difference. 831.25. So this one's a little different in height. So this little section is showing you the footing, the wall, the floor at one level on the inside, the floor at another level on the inside, and the wall as it extends. And this height changes. So you've got two levels of floor across this section. 16. Okay, right here, section 16 is showing you that the wall changes in height, the floor changes in height. You got a level line and a level line for two different floors. You've got a wall and this footing, this footing and this wall that extends up all the way up to another level of a footing at another level. So this one's detail 4 and this one's detail 16. So there it is. You can see that ramp, that docking thing that they were talking about. It's like they have a basement underneath and you can drive a truck underneath to load onto this floor. So you've got this floor here at one level, and then you got the other floor at this level. And, I mean, this is a fancy house. Lots of underground work. Columns. Footings wider and thicker due to concentrated loads. So you're going to have wider and thicker because they carry a lot of weight. Chimneys and other concentrated loads require thicker footings. So if you got a big giant stack of bricks that goes 2 stories, well, it's going to push its way down to the ground if it's too soft. So you would put footings with thicker footings, heavier footprints, deeper holes. So here's some careers in concrete construction. Lots of opportunities. You can be a laborer, you can be a carpenter, you can do the masonry work, you can do finish work, you can do reinforced steel installers. Those are all the different jobs. It's fast-paced, it's heavy work. You're outside working in the sun a lot, but you know, if you're good, you're fast, you're strong, and you enjoy seeing things get built together and pretty fast too. It's fun work. You learn the skill on the job or you receive training. So training like this just gets you enough to think about what's going on so that when you're on the job, you're a little bit more better at learning on the job. So you can never replace experience. So if you are planning on becoming a manager and not actually building concrete, maybe you're estimating, try to work with a concrete company. Get an internship, volunteer, offer your services, shadow. Say you're looking to get experience and you'll volunteer to work next to a manager or a foreman or somebody to learn the job. And you'll work in different weather conditions. I mentioned that. So you get your form workers. These guys are building, you know, big concrete pours, big rebar cages. You got these guys that know how to do the finish, the flat work. Some of them do it by hand. Some of them do it with these walk-behind machines. The foundation, it's the base of the building. It transfers the weight of the building to the footings. The footings is the foot laid on the ground. It's the contact of the ground. It can be poured in place or it can be made out of blocks. And both methods usually will have steel in them with rebar. An expansion joint is placed between slab and a wall to prevent cracking. I mentioned it can be a joint between two walls. It could be a space between a floor and a wall. And it allows for movement and then prevents cracking. Here's an example of a foundation wall section. You can see here's the footing of the wall, the steel bars here and here, as you can see called out number 4 at 11 inch on center. You can see that it's got a 1 foot on the outside, 1 foot, 3 foot 2 on the inside, and it's got an actual footprint of 5 feet 2. So it's got a big old fat 1 foot thick footing, but a big wide foot. And then it's got a wall that goes 2 feet 6 underground and 4 feet 6 above ground. And then you can see that above it, the top of the wall has its height, and then there is a wall that rests on top of that, and another floor placed on top of that. And on one side it's higher than the other, and that it's got more dirt. This wall is supporting dirt at 2 different to keep the load to hold back the dirt on one side. So this is designed to carry a heavy load, this particular foundation. A lot of material being used here. Green building, material storage. So damaged or lost material causes waste, right? So you got to put the material away. It's got to be in a dry place. If you leave it, it can't be touching the ground. It has to be up on pallets. If it doesn't, it'll draw moisture, and then and especially if it's cement or concrete pre-mixed, it'll go to waste. So protect your materials from theft and the weather, and keep materials organized so you can get to them easy. Concrete can get messy. This is a type of schedule, a drilled pier schedule. So it shows you locations and sizes. So this is a 30-inch, and when you see a circle with a slash through it, it means diameter. So it's saying the pier that gets drilled at 30-inch diameter, it's going to have 5 number 9 bars in it. And it's going to have ties in it, number 4 ties, or number 4 bar at 18 inches. And then, there are times where you're going to have a schedule that's going to point to the location where piers are going to go. And these piers vary in different sizes. You would refer to this schedule so you'd know to drill the right size hole for that pier. And over here is the grade beam schedule. So again, lineal footage of a type of foundation. And this is going to tell you the beam marks, the beam types, so there's locations, the size. This is 28 by 36, then it changes from 36 to 48, and then it changes from 28 to 36. So there'll be marks or locations, the bar mark, the bars. So it's just saying the bars is the steel, 4 number 9 at mark bar T3 at F. So these are just locations saying how much steel is going to go at these different locations on the plans. The grade beam span from footing to footing. So it's this concrete beam that goes all the way across to another footing. And they're formed on the ground or by a trench. See, they just dig a hole in here and make a beam underground, and they go all the way across until they reach the other footing. And they span over weak distributed spots in the soil. So they just help prevent the building from sinking into itself. And auger cast piles. They're drilled with an auger. So an auger is a drill bit for dirt. And they can do 12 inches to 14 inches in diameter. and while the drilling shaft is being removed, concrete is pumped into the hole. Top with the pile cap to create a load carrying system. So it's just saying when you pull the dirt out, then you can pump concrete into the hole. And so you've made cast piles. You've made the dirt into a cast, and you've made with an auger, and you have concrete piles. Basically a long column. And types of auger cast piles: there's friction pile and pile drilled and socketed into rock. So a friction pile is just being held in there. It's just in the dirt, just the dirt's holding it. And then some piles are drilled so deep until they rest and they hit a base rock. So here are some of those piles. You see these big round square, these circles represent the drill holes, the piles. And then on top of it is a pile cap, a square box that rests on top of those. And then on top of that, a column. So it's just, and then you can see these, sometimes they drill and they get so deep until they reach concrete into rock. So that if this soil is really soft, these can't just push deep into the ground. So this one's really hard to read. Got a lot of details on it. But let's see if it says what the type of plant it is somewhere. So these are this is a plan that has a lot of auger cast piles. You can see here with these squares with these circles around them all over here. Squares with circles around them all throughout the foundation here. So there's a foundation that's poured on top of these holes that are drilled into the ground all the way around the house. And then it shows an illustration of it. They're drilled to a design depth, usually 18 inches to 72 inches in diameter. That's 6 feet. When the drill is removed, the bottom is tested for load capacity, soil. So they want to make sure that the dirt is much more harder and much more compact than it is, deeper than it is up above. And knowing that it will hold and carry a load capacity. And then steel reinforced cage is installed and the hole is filled with concrete. So that's what a caisson is. You fill a hole and then drop a cage of steel in there. And so the grade beam or the auger cast piles were a bunch of holes drilled deep into the ground like nails, and then a square cap put on top of that, and then a wall on top of that. Looks very labor intensive, but I guess you do that for a house like this, where the ground is really soft and you've got to put them all over to keep the house supported. Then the caisson is where you drill the hole, and then you drop in a cage of steel. You'd still have a cap, but it's just to distribute weight. And they're little squares. They're like footings. Steel pile, H-shaped H pile or round pipe pile. So this one has steel piles that are jammed into the ground like nails. They're hammer driven into the ground, and then they pour this little square concrete pad on top of them with the steel going into the and then the piles are capped to create a final load carrying system. So these 4 pieces of steel, big guys like this, will be power driven into the ground, and then on top of that steel, this little square cap will rest, and then on top of the cap will rest the pier or the column that supports the building. So the weight of that building is not pushing that foot down in the ground. It's got those steel piles underneath carrying that weight. So here's a close-up view of the steel piles buried under the ground and of the square concrete cap on top of it with the column on top of that. Here's the column on top of the cap, which is on top of the pile, and these piles are buried into the ground. Elevations of foundations. It's a measurement referenced to a known point, and it's a vertical height of the building, right? So we're looking at the elevation from the lower section to the upper section from the side view. A foundation elevation marked on a foundation plan view. Each project will have its own special elevation design system. So it's just saying there's going to be a way that you get to read them. They're going to look similar. Slab on grade construction. So that's when concrete is poured at ground level. When it's subjected to settling or heavy loads, it's reinforced with a wire fabric. It's like when you say wire fabric, it's not material, it's a metal fabric made of wire that might be 4x4 squares or 8x8 squares or 3x6 rectangles. And you'd lay that in, and it's like a steel wire, a mesh that you would lay into the concrete to reinforce the slab. You could also put bars of steel, reinforcing steel. Reinforcing steel used to help resist cracks and the propagation of cracks. So sometimes you get cracks, but they stop once they hit the steel. Floating slabs use a monolithic slab construction. Slab and footings poured as one continuous unit used to turn down footings. So a slab on grade is just a flat slab right on top of the dirt. But then what if I had a slab with footings all the way around it? So around the perimeter I have a trench that's dug 12 inches deep, 18 inches wide, and then back up to the original thickness. So it provides that additional reinforcing for walls. And when it's done monolithic, it's all done in one pour, not separate. Here's that example that I was showing you of that monolithic slab with the footings poured and the slab built on top of it. You've got your gravel. From the outside, you've dug these channels all the way around the outside of your slab. But inside of the slab, you've got gravel. You'll even have a layer of plastic, what they call a vapor barrier. That'll keep moisture from coming up into the bottom of the concrete. This one does not show a vapor barrier, but it's usually just a piece of plastic. Here the red represents the steel bars that are going to be laid inside the footing. Then this dashed line, I think that just, I'm not sure, that just represents, I'm not sure what. Oh, it's the stirrup. It's a part, there's a little ledge, a little step in the concrete around the outside here. Over here it's telling you that there's number 3 at 12 inches on center both ways. So it's a wire mesh, a number 3 wire with 12 inches on center going 2 directions. Here it shows you that here's the grade and the slab sticks up out of the ground a minimum of 6 inches. And I guess this is the frost line, so it's below, this is how deep it goes, below the frost line. Whatever that depth is. You can see it's got a little bit of a slope angle to it. It's got, again, 2 number 4 bars continuous all the way around. These are the same bars at that same level, being bent and going all the way around. expansion joints. So here is the expansion joint. Here is the wall. Here's the ground. There's that vapor barrier telling you underneath the floor. And this floor might change in its thickness or change in its size based on the temperature. And this gap will either close or open. So by leaving a half-inch expansion joint, you allow for movement so that it prevents the floor from cracking. This is just showing you in another elevation or detail this floating slab. See, it's also has an expansion joint. It's a floating slab between two T-walls, and it's literally resting on top of gravel, on top of dirt. Here, this slab rests on top of the footing. So the concrete footing is holding that slab up over the dirt. Here, the dirt is holding the slab up. And should this start to move, the dirt move, this floating slab will float downward and may move. But you've got this little, it may drop down even. If it drops down a little bit, it'll drop down a little bit. But it's designed because it's got the right gravel and compacted fill of undisturbed soil. It shouldn't move. But it allows it to move a little bit. Thickened slab on grade walls, so there's certain areas in the plan view. Here you'd see dashed lines. That's what it's showing you, that it gets deeper here in the section view. Interior and exterior slab on grade. So this is the interior of the house. Here's the wall. Here's the finished floor. Installed stone and resin finish floor covering. Here's a wall. Structural drawings for foundation size. The steel. You can see the slab, 6-inch thick, 4,000 psi concrete floor with 6x6 W2.9 by W2.9. That's just saying this wire mesh. And on this side, a 6-inch, 4,500 psi concrete floor. So, again, I'm not sure which one is interior, which is exterior, but this is definitely a heavier duty floor. And it's got 6x6 wire mesh. Different wire mesh. 9, W9, 2.9. Nope, same. Compacted gravel under base. So you've got gravel under here. Gravel under here. So it's through west wall of hard lines. So I can't explain more than that. But one's an interior floor, one's an exterior floor. I'm guessing this is going to be the interior floor since it says finish, and it's got this symbol here which calls out the finished elevation. So here's what you can see. You've got these slab on grade foundation with interior and exterior beams. See, these are the beams going, the little channels. But here you've got on top of the plastic, you got the wire right up above the plastic. So this is like 6-inch slab until, except all the exterior, that's a beam all the way around. They crisscross, create a grid. So it helps support itself. It's a slab on grade foundation. So it's a foundation and slab. This is done in a monolithic pour. You can see it's got some electrical, some other underground objects that are going to be poking out. Maybe some plumbing that's going to be poking out. Here's some waterproofing. You see here, this guy's standing in what's going to be filled up with dirt. So he's on the outside spraying this like black tar rubber type spray that will dry and create rubber film. So when they fill that area up with dirt and gravel, water won't penetrate through the concrete. It provides protection against underground water. And see, he does what's called a mopping with an asphalt coating. And then they put crushed rock at the bottom that also covered with vapor barrier. That also keeps the water from collecting and pooling up. And then they put waterproofing specified with some type of engineering system. Here's a water stop. Water stops, it stops water transmission at the construction joint. So, see, here's the wall with dirt. You've got this waterproofing. You've got dirt. You've got gravel. See the granular fill. This area's gravel. You've got water that may collect in here, and water goes down and gets to the bottom, and it hits this pipe, which will collect the water and take it away somewhere out. So it provides a water stop system. It keeps the water from continuing going underneath. Oh, and yeah, 6-inch PVC water stop. But it's pointing to the keyway. I believe this pipe is what they're talking about as the water stop. A 6-inch PVC polyvinyl chloride. That's that plastic pipe with drainage. I think this might be an error. This should be pointing to that circular where it says drain. Okay, that's it. I'll start another video. I'll do the test your knowledge, and then I will go ahead and see if I can make another video on the activities. I'll try to blow through the answers as best as I can. Help give you guys a little head start. I won't answer all the questions, but I will see. I'll try to answer them in such a way that will help you get through them quickly. Okay? So that's it for now. Thanks a lot. See you guys soon.